This morning, while passing by a wind energy construction site, I remembered that I still had a few old computer cooling fans at home. At first glance, they looked like scrap, but if they still work, maybe I can turn them into a useful DIY device. First, I need to test them. I start testing each fan. First, I use a 12-volt battery to power them. With computer cooling fans like these, if the DC motor inside is still good, the blades will spin as soon as the correct voltage is supplied. In DIY, small parts like this often have more uses than we expect. An old fan can become a cooling part, a ventilation part, or even the core of a homemade mechanism. Do not underestimate it. Sometimes the thing forgotten in a corner is exactly the missing piece for a new idea. Luckily, both of these cooling fans are still usable. So I already have the first material for this project. Here I have a piece of 110mm PVC pipe. I tested the size earlier and it fits this fan quite well. But the next thing I need is not the whole pipe. I need a flat PVC sheet. Since I do not have a suitable sheet ready, I will reuse this pipe. I cut it open, heat it until it softens, and press it flat. In DIY, sometimes a small homemade part can guide the whole project. Next, I use another piece of 110mm PVC pipe to draw a circle on the flat plastic sheet. This circle needs to match the inner diameter of the pipe. Now I cut out this circular piece. I need a flat round plastic part that fits tightly inside the pipe. If it is too small, it will be loose. If it is too large, it will not fit. After cutting, the edge is still rough, so I sand the edge until it is smooth. Its diameter must match the inner wall of the pipe. A small mistake here can make the later assembly unstable. Now I mark a 4x4 centimeter square in the center. At this point, many people still may not know what I am making. And that is the interesting part. The key is not the fan or the PVC pipe. It is a small component that will appear next. After cutting, the plastic piece looks like this. The square opening in the center will hold the main component. This is the key part, a TEC 12710 peltier module. It runs on 12 volts, draws about 10 amps, and works at around 89 to 100 watts. When current passes through it, one side gets hot and the other side gets cold. This is the peltier effect, often used in mini cooling systems. Now I mount it onto the prepared PVC piece. Next, I apply thermal paste to the hot side of the peltier module. Then I attach the aluminum heatsink firmly. This step is very important. The hot side must transfer heat to the heatsink as quickly as possible. If it is not cooled properly, the module will overheat. Then the cold side will not get cold enough and the component may be damaged. For the cold side to work well, the hot side must be cooled properly. Now I return to the original 110mm PVC pipe. First, I mark 2 straight lines around the middle of the pipe. The goal is to create a separate hot air exhaust path. With a peltier module, if you focus only on cold air and ignore the hot side, the project will fail quickly. One side absorbs heat to create cooling, while the other side must release heat. If hot air is trapped inside the pipe, the cold side will lose efficiency. It is like running a refrigerator while keeping the condenser inside a closed box. That is why this pipe section must be handled carefully. Next, I cut a small hole in the PVC pipe. This position is for the switch. The switch will make the system easier to turn on and off. Now I test fit the switch. I check whether it fits, whether it is loose, or whether it touches the pipe wall. It is small, but if it is crooked, it will be hard to fix later. Next, I decorate the inside of the fan body with a 12-volt LED strip. This does not change the main working principle, but it makes the device look more interesting when it turns on. In DIY projects, sometimes a small light can make the whole build feel more alive. Now, back to the peltier module. The thermal paste has settled and the aluminum heatsink is in the correct position. Before placing this assembly inside the PVC pipe, I need to make two small holes for the wires to pass through. These holes help keep the wiring neat and prevent the wires from getting trapped inside the body. At this point, I realize I test fitted the switch but forgot to remove it. To insert the peltier plate inside, I have to remove the switch first. This is a very normal DIY mistake. Doing the technical part correctly is not enough. You also need to remember what you just installed. I remove the switch, place the plastic piece correctly, and continue. Now I run the wires through. I want all the wires to go in the same direction toward the switch. That way, wiring and checking later will be cleaner, easier to repair, and more professional. After running the wires through, I use glue to fix the flat plastic piece inside the pipe. It needs to stay firm so it will not vibrate or shift when the mechanism is working. The main parts have appeared. These are the two old computer cooling fans I tested earlier. One fan will be installed on the cold side to blow cool air forward. The other fan will help cool the backside and push hot air out. I run the wires through the rear switch area, then glue the fan to the PVC pipe. The structure is almost clear now, but whether it works or not depends on the power test. On the back side, I prepare a CPU cooling assembly. It includes a cooling fan and an aluminum heatsink. The heatsink contacts the hot side and absorbs heat. The fan blows air through the heatsink and pushes the heat away. I use this old computer cooling assembly to cool the hot side of the peltier module. Now I start working on the wiring inside the device. For a 12-volt DC system, separating the positive and negative wires correctly is very important. The positive wire group will go through the switch, so it can control the power for the whole device. When the switch is turned on, power will be sent to the fans, the LED strip, and the peltier module. The negative wires will not go through the switch. I will connect them together to create the common return path for the circuit. If the polarity is wrong, the device may not work properly or the components may heat up abnormally. So I check each wire carefully before soldering. Next, I solder the positive wire group to the switch terminal. Finally, I check every joint to make sure the wires are secure, not loose, and not touching any unwanted contact points. In DIY electronics, sometimes one tiny solder joint is enough to cause a problem. Next, I attach the fan stand that was already made from PVC plastic. This part helps the device stand firmly and makes the airflow direction easier to adjust. After that, I fix the fan body onto the wooden base. This base keeps the device more stable while the fan is running and helps prevent shaking or tilting during use. This is the final key part, a switching power supply. It is rated at 120 watts. The input uses household AC power, about 185 to 240 volts. The output is 12 volt DC with a maximum current of 10 amps. Now I connect the switching power supply to the fan system, the LED strip and the peltier module inside. This supply is suitable because the peltier module needs strong and stable current. If the power supply is too weak, the module may not get cold enough. If the polarity is wrong, the component may overheat or fail quickly. So the power connection must be firm and correctly wired. The project is complete. Now I will plug it in and see the result. This is always the most exciting moment in every DIY project. Here I have an electronic thermometer. The room temperature is about 31.9 degrees Celsius. I will use it to check the cooling performance directly. If the number drops quickly, this mechanism is really working. And the result is quite surprising. In just a few seconds, the temperature drops quickly and the airflow feels much cooler. From a few old parts, this DIY project works better than I expected. Please like, share and subscribe for more ideas.